Before we get started with this story I want to tell you, I would like to apologize because at lunch, someone approached to me about the title of my talk. So I wrote it, Ali, yeah. And, well, this person was absolutely right. He said, or she said, sorry, this is not accessible at all. And I realized it's absolutely true. So I made an assumption that everybody would understood. So I apologize for that. So that's an example of things that can happen. And I would like to tell you a story, which is about a couple who found their way in life, and a lot of stories have been told about this couple. For example, their origins in their origins in Oahu, one of the 8 major islands of the Hawaiian archipelago. And many moons have rose and fell, and shiny rainbows would ascend to the sky after the tropical rain. Probably the same ones Captain James Cook first saw when he first sailed past the island. And their love was bounded by the jungle air and the salty breeze and looking for adventures and freedom and a sense of purpose. And time goes by. This is kind of not really working. So, no. Time goes by, and this couple decide to move to Germany to pursue a business venture. And the couple founded a sustainable clothing label. They both of them had a passion for sustainability, style, and fashion. She already had a long history as a seamstress and pattern maker, and he was influenced by his seamstress grandmother, who used to sew him garments according to the epoch, from Miami Vice, pastel color suits, to neon color streetwear inspired on the Fresh Prince of Bel-Air. This is really not working. So anyways, they bootstrapped their business, this couple, and they needed to launch an online store. But at the time, cash was short, and finding an agency in Germany that could do that for an affordable price was for a bootstrap business really, really hard. But one day, they actually found a small agency who was willing to do the online store for them. At the time, this was development only, so they still needed to prepare some screens, some UI design. And with little to no knowledge, the man prepared some screens. And surprisingly, the agency liked those screens a lot. And you have to consider that until this moment, this man has nothing to do with the web nor with computers. He didn't even have a high school degree for that matter. This is going too fast. So one day, the owner of this small agency had this wild idea. And he said to the man, I think front-end development is something that you will really love. So what about if you learn front-end development, invest the next 6 months learning, you will help us build this online store for you, and we will accept that as the payment. And of course, the man knew that would be a one-in-a-lifetime opportunity, and he took it. Since then, he never looked back, and he never thought about it changing his life in such a profound way. Programming and front-end development became something that he's really passionate about. And my name is Mauricio Palma, and I assume you already knew that was the story how I became a front-end developer. And as already mentioned, I'm one of the co-founders of Wood Like Ocean, where we craft swimwear out of ocean-recovered fishing nets. And we like to experiment with this concept of using waste for producing new products. I also work as a product engineer at Sinashkara. And by now you might be wondering, that's a cute story, but why are you telling me this? Well, I bet there's a lot of us in this room who are self-taught developers. Now by raise of hands, how many of you are self-taught developers? 50%. And now imagine that this information that we use to become front-end developers would be only available to a selected group of people, that all of us were not invited to use this information. And when we don't think about accessibility, we are excluding people and communities, and we are actually preventing the web from evolving, from technologies to evolve. And for many of us, it has not only been an opportunity to find a career that we love, for a lot of people, and a lot of us, has become an opportunity to get out of financial distress, an opportunity to get out of poverty, an opportunity for a better life. And today we will be covering some automation techniques that hopefully will make our life much easier to test for accessibility. But a word of caution, like every new shiny toy that we get, we cannot automate everything. So we are talking about accessibility can be 30% of the accessibility issues can be covered with automation. Y ahora, es muy importante tener en consideración que implementar accesibilidad es un tema muy difícil. That was awkward, right? And now tell me, besides Ramon and Pilar, and probably Raul too, not the other Ramon, sorry, that's another story. Sorry. You could not, this thing's not working. So anyways, let's reflect about how you felt. So how many of you understood what I was saying? That's a lot, but there's a few of them. So you're not part of this test that we're doing. But let's reflect for a second about how we felt. When I was showing unreadable slides and when I was speaking Spanish, maybe you were feeling irritated, maybe frustrated, maybe even angry or anxious. And this is what we're doing every single day to about 217 million people with visual impairments. We deny them access to our personal and professional lives. And what if I can tell you that exclusion literally hurts? Neuroscientists have found out that the emotional pain of exclusion overlaps with the physical pain, at least how our brain processes it. And like I said, there are 217 million people with visual impairments, of which 36 million are blind. And in Europe alone, there are about 30 million people with visual impairments. And the truth is that we as developers, we don't pay much attention to these numbers. How are we supposed to if we're not really aware about it? So how are we supposed to fix something we don't know? And that's what I hope, that we can become more aware about accessibility, about thinking and including more people in our applications. And the great thing about it is we can put accessibility everywhere in different software layers. Like we can put it in our build pipelines. We can put it in unit tests, in our underlying UI UX, which is, of course, one of the most important parts. And so the whole idea about color contrast automation came to me one day when, at the agency, we received from one of our clients a new color palette with about 50 colors. And accidentally, a few days later, I realized how this designer was checking every single color, one by one, manually, until it will find a match. And the result was amazing. The designer made this incredible color contrast accessibility chart. But if we measure this approach with time complexity, it would end up with something with n squared, meaning that the time to do this depends on the amount of colors that we need to check. So if the corporate identity color palette has something about 50 colors, then we're talking with a worst case of 2,500 manual iterations. The worst part of it is we're checking for AA and AAA. So in the worst case, it would take 5,000 iterations. And hopefully you're starting to get my point by now. This is very time-consuming, error-prone, not really reliable, and the worst part of it is we cannot really use it in our web application. And that's why I wrote this small JavaScript application that will hopefully give us a raw idea of the kind of things we can automate. And for that, I used Next.js, TypeScript, React, and Emotion, which is not really relevant, but people sometimes ask. And let's cover the initial requirements. So the first thing we want is we want to upload a color palette. Let's say for the first version, like a JSON file, and each object would contain a color name and a color value. Now, the second requirement that we need is we want to upload these colors, and we want them to automatically group each color contrast combination for each color. And for that, we want to use the guideline 1.4 of the Web Content Accessibility Guideline as a baseline of our rules. So let's take a look at that. That means that we want to cover AA and AAA color contrast. And A, AA, and AAA are the 3 levels of conformance as defined by the Web Content Accessibility Guidelines. And they pretty much allow us to provide more accessible and usable content for web users. So a minimum color contrast, when we talk about AA, it is a contrast ratio of 4.5 to 1. If we talk about AAA, then we're talking about a contrast ratio of 7 to 1. And there are some exceptions, of course. For large-scale text, when we talk about AA, we could have a color contrast of 3 to 1. For AAA, 4.5 to 1. And large-scale text can be defined roughly as 24 pixels or 19 pixels bold. Logos and brand names have no minimum color contrast requirements. And inactive UI components that are pure decorative or hidden or maybe part of a huge visual composition don't have a requirement neither. And offering enough color contrast, it is important for people who has a low vision, for them to actually read the content that we're providing through our web apps and our websites. And it is important for us to consider too, people with color blindness, which is a disability too, might perceive contrast in a different way because color deficiencies might affect how color is being perceived. So basically, these are our key metrics we need for this little algorithm that we will write. And we can now check the calculation for the relative luminance. So I would like you to take a look at it for a second. You all ready? More or less? And when I just first saw the Web Content Accessibility Guidelines, I thought that's a lot of information to digest just for relative luminance. So I would like us to break things into smaller steps, and we will divide the concept of color, or we will not. Color, it is divided in 2 parts, basically luminance and chromaticity. Luminance is the photometric measure of luminous intensity per unit area of light in any given direction. And it is worth taking in consideration that objects actually don't have color. Objects give off light that appear to be like color to us, but color only exists in the eye of the beholder. And for relative luminance, we need to use this photometric measurement of luminance for our calculation with 2 normalized values. 0 being the darkest black, and 1 being the lightest white. And to calculate the contrast ratio, well, we need, first step, relative luminance, then the contrast ratio, we will need to calculate the luminance in the sRGB working space. And sRGB means standard red, green, and blue, which is a standard, a very old one, was made in 1996 by HP and Microsoft. And basically, what it does, it was designed to represent colors the same way across different devices. So it has a very small color gamut, which can be really easily reproduced by most devices. And it is by default the color space that we use on the web. So when we're tweaking colors in CSS, these are all based on sRGB colors, like the color keywords. By the way, Papaya Whip is my favorite one. And all these colors are based on the sRGB. And an interesting fact, too, is that RGB works in a very similar way as our visual system. We have 3 different channels for conveying color, which come from different types of cone cells in our eye. And those are the reasons we will choose to use RGB for our calculations. Now, one more thing. We talk about chromaticity, which define color or the quality of color regardless of its luminance. And it consists of 2 parameters that we have heard a lot, hue and saturation. In the XY color space, the lowercase x and lowercase y represents the chromaticity. And in the vertical coordinate, the uppercase y represents luminance. And the number of parameters also follow trichromatism, which is based on our visual system. So let's calculate that color contrast. So basically, we will divide each entry by the full intensity of each primary color, which is 255. And we check it if the value is less than 0.0329, and we will crunch some numbers. And this we will do in every single entry, meaning for red, for green, and for blue. And this is how can we get our luminance. So we will use this same function and make the calculation for each entry, add it together, and we get a relative luminance. So that's all we need to calculate the relative luminance of a color. And for the contrast ratio, basically what we knew is the relative luminance. And very important for us is that light and dark always has to have the same order, because we want to divide the less luminance, the lighter luminance with the less luminance. And well, for now we can check 2 colors, which is not really useful by now. Well, it is useful, but we want to automate n amount of colors. And we want to do this in a performant manner. We don't care if it's on the server or on the client. And remember our mantra, accessibility everywhere. We don't care what's going to happen. And because of that, we're covering two basic algorithms. And the first one that will help us to work with this color list will be, we will be sorting colors. And if you have heard of it before, Quicksort is considered to be a fast sorting algorithm that follows the divide and conquer approach. It uses a basic principle that it is being used in complex applications like file search or data compression. And this is basically the implementation for it. You don't need to read everything. It is just for the example. So we want to compare 2 colors, meaning we need to provide first a function, which is our callback. In this case, we're going to be using the luminance. And then we will have a pivot. We have 2 colors in each end and a pivot, which is necessary for this partition function that will give us, which is the current low and high value, or the other way around, low and high. So the pivot divides this array in 2 halves. And normally, when you're writing an algorithm like this, you want to pick a good pivot, which is necessary for a performant sorting algorithm. But for the example, we will just pick the middle. And this is how it works visually. So we're breaking our problems into smaller problems. The pivot would be the black the black square, and we start checking until we find a match. And basically, we're going to swap those elements in this array. And I would recommend to do that in memory if you have a big list in order to avoid have a better memory. And basically, we repeat this process until we have sorted all of our colors. So at the end, we have a sorted list, which is important for the next step. We want to search for the AA and AAA color contrast. And we will be, for search, we will be using something like a binary search, which is also a very efficient algorithm to find something in your list. But it is important that when we're searching for an item or for a group of items, this list needs to be sorted. Now, this is how it works. We will check for AAA. So we need a contrast ratio that is greater than 7. And basically, this is a divide and conquer approach too. So we search in the first half. We didn't find a match, so we already know, OK, so there's no AAA color in my first half. I can continue in the second half, and probably I will find a match. Now, there are some special things I included here, like a previous and next value that are always next to the mid, because I want to see if I'm in range, because I'm not looking for 7 specifically. It can be 7 or greater than 7. So I'm always moving the previous and the next values with the mid too. And whoops. So basically, that's all what we need, all these 4 steps that we did to automate the colors. And we need to do something about it. So basically, at this point, we have found all of the AA and AAA color matches. And we want to do something with this data. So let's create something like an enhanced color. So I have a factory function that will return an object that contains, I think this is not what it is. It contains the AA and the AAA colors that we will have automatically in the application. And I have a little demo for you prepared, so let's check that out. So basically it is, so we're using this under the hood. We said we want to upload a color. Maybe not the best for a designer, but we will pick a JSON file for now. And this JSON file contains all possible colors that a color palette could have. And this is basically what it takes. At this moment, all of these colors are the enhanced colors, meaning they all know all of their possible AA and AAA color combinations. So for example, I'm able to see, for example, Lucky Point, and I will see all possible colors in this color palette, and it will tell me all the contrast ratios that I have. So for a designer, it is very useful because it automatically knows, OK, I'm able to work with text and background with these colors, and the same it would go for AA as well. And we will also find out there would be some colors that have no, well, this one has, but we have some colors somewhere in the middle which don't have a AA or AAA contrast ratio. And this is just one of the use cases where we can put this algorithm. We can use it, like I mentioned, in our unit tests to check if the color contrast of a React component are, and maybe it needs to, we would put that in our pipeline. So we're only building when these accessibility requirements are being fulfilled. So I think one last thing. So you can check it up in GitHub. So you can play around with it. You can use it. Maybe you can create a package out of it and use it in your own projects. You can make it better. If you have a better use case, you can talk to me, and maybe we can do it together. And that being said, thanks.